So when a user asks any question to an LLM, we know LLM has been trained with some publicly available data, so the LLM can answer with its generic intelligence. Otherwise, if the LLM cannot answer with its generic intelligence, then we need to train the LLM with your organization's domain-specific data by loading your documents using document loaders and then chunk the input document. We've already learned different chunking methods in the previous lectures, right? And then we have seen how to create embeddings because LLM cannot understand text and it can only understand numbers, right? And then we learned how to store these embeddings inside a vector database and provide LLM access to this vector database so that the LLM can answer for any domain-specific user question. And this process is called RAG, Retrieval Augmented Generation. We have seen this already. And we have also learned different prompt engineering techniques, that is how to ask a right question to get the right answer from the LLM. And then we have seen how to provide memory to an LLM. And we also learned how to bind different LangChain components with LLM by using chains, right? Now let's learn about tools and agents. Okay. So by using LangChain, we can create agents too, but the limitation with LangChain is it is limited to one particular task, meaning only single agent. That's why we will be learning CrewAI, which is a multi-agentic framework, right? So what is multi-agentic framework? In the context of language models and AI, a multi-agent system involves multiple independent actors, each powered by language models collaborating in a specific way. So that is nothing but multi-agent system. So the term agent is not new to you. When you power an LLM with tools meaning providing external world access to LLM, that is web search or web scraping or web crawling or Microsoft product access or Slack access or WhatsApp access, etc. right? And when LLM can remember the context, right, that is the memory, and when you ask a right question by using different prompt engineering techniques, then LLM will be able to predict the right answers, right? So multiple agent means every single agent is different than every other agent, and each agent will do a specific task. That is, more than one agent can perform a task. For example, let's say you have multiple agents here and one agent can summarize the text of a content. For example, you want to use GPT 4.0 to perform this task. And another agent, agent 2, you can use as market research analyst, and this agent can perform a task. For example, let's go to the internet and search the web, convert that to a markdown format. And you already know LLMs are markdown friendly, right? So for example, let's say we want to use an open source model like Mistral to do this task. And let's say another agent, agent 3, which can write SQL query. Maybe we want to use another open source model like Qwen to do this task, right? So what we are doing here, we are using multiple agents and assigning each agent to a different LLM, and we are assigning different tasks. So every agent can have a different LLM assigned to do a particular task, or every agent can have its own memory, or every agent can have its own tools to access the external world. So this is nothing but a multi-agent system, right? So what are multi-agentic frameworks? We already learned all the concepts. We need to learn a framework which will support this multi-agent, right? And we have different multi-agentic frameworks available. For example, CrewAI, AutoGen, LangGraph, and we have several other frameworks available. CrewAI is used to streamline workflows across industries with powerful AI agents, and it is used to build and deploy automated workflows using any LLM and cloud platform, right? So this CrewAI is a popular one. It's user-friendly framework and it is easy to understand. And this is the official documentation of CrewAI. So let me take you there. So crewai.com right? So this is the official CrewAI documentation. So you can go through this when you have some time. And this framework is used to build multi-agentic generative AI applications, right? And the next one is AutoGen. AutoGen is a framework for building AI agents and applications. And this AutoGen framework is developed by Microsoft. And when it comes to AutoGen, we have streaming kind of live feature available with AutoGen, and that feature is not available with CrewAI. So depending on your requirement, you have to pick the right framework. And the next one is LangGraph. This is a framework for building AI agents that can handle complex tasks, right? And LangGraph is developed by LangChain. And by using these frameworks, we can build multi-agentic applications. And there are other multi-agentic frameworks available too, but these are some of the famous ones. So let me take you to AutoGen as well. So like I said, this is developed by Microsoft, a framework for building AI agents and applications. So this is the official page of AutoGen, right? And let me show you LangGraph as well. So you can see by using LangGraph, we can build multi-agentic frameworks and solve complex tasks, right? So this is the official page of LangGraph. So by using these multi-agentic frameworks, we can build multi-agentic applications. And there are other multi-agentic frameworks available too, but these are some of the famous ones. Okay. And we will learn CrewAI multi-agentic frameworks in this course, so we can build multi-agentic generative AI applications. Alright, thank you. So we will learn CrewAI multi-agent framework in this course, so we can build multi-agentic generative AI applications, right? So CrewAI is built on top of LangChain, and this is a multi-agent framework. It supports agents working together. In layman terms, an agent is like a human being, right? And each agent will be assigned with LLM, tools, memory, etc. And each agent will perform a task. And these agents can work either sequentially, that is one after another, or they can also work in parallel and perform the assigned task. That is either sequential or parallel. These agents will generate the final outcome when they are done with their tasks. And CrewAI has very good documentation. So let me take you there. So this is the official page of CrewAI, where you can see all the different components of CrewAI. And I will talk about all these in detail in the coming lectures. But if you are interested, you can go through this documentation as well. Okay. So why are we learning this CrewAI framework? So that we can perform complex tasks which have multiple steps involved. For example, assume you are a database developer, and assume someone has given you a CSV file which has some data in it, and your task is to load the CSV file to a SQL table, generate a report, and send an email. And let's say if the user is asking you to generate the same report every single quarter based on the data you imported from a CSV file to a table, and this is nothing but a repetitive task, right? So in this case, you can try to automate this task, right? For example, you have different tasks here. That is to log into a database, write a SQL query and run it, extract the results, and then generate the report and send an email, right? And here each task is dependent on the previous task output. And we know an agent is like a team member who can perform a specific task. So you can assign each task to an agent, right? So to perform all these tasks, each agent can work in sequence and generate the output. So one agent can log into the database and run the SQL query and extract the results. So that is task number 1. And we can assign this task 1 to one agent. And another agent can help you to generate the report out of the extracted results from the SQL. So it will take the output of the first agent and generate the report, right? And let's say you have another agent here, and this agent which has integration with Outlook to send an email. So it will take the output of the second agent, that is the generated report, and send an email, right? So you have three agents who are working for you, and they are working in sequence, one after another. Each agent is dependent on another agent. So the second agent will take the output of the first agent and generate the report, and the third agent will take the output of the second agent, that is the generated report, and send an email, right? So now you get the basic idea on how multi-agent applications look, right? And we will come to the implementation part in the coming lectures. All right, thank you. So before we build multi-agentic generative AI applications by using CrewAI, first let's learn all the components of Crew, right? So we have process, agent, task, tool, and memory system. So what is process? Let me zoom in. Process defines how agents will work with specific tasks assigned to get the work done. For example, in our example, process is the whole architecture. That is, the process is sequential in our example. We cannot send an email until the report is generated, and the report cannot be generated until and unless we get the data, right? So this is a sequential process. That is, the process defines how the agents are working. That is, are the agents working in sequential or in parallel or hierarchical, right? So that is nothing but process. So this process object is the workflow or strategy the crew follows to complete the tasks. And we have two strategies, like I said, defined by the CrewAI framework: sequential and hierarchical. Sequential means the output of one agent will be input to the another agent, and they wait for each other. And this sequential strategy executes the given tasks in sequence and in a particular defined order, right? And this sequential strategy is ideal for any pipeline type of work where each agent performs a specific task and passes it to the next agent. And you will understand better when we implement the project, right? And the second one is hierarchical. And hierarchical strategy organizes tasks in a hierarchy. And these tasks are delegated in a hierarchical fashion and executed based on a chain of command. And this hierarchical strategy is like a manager assigning the work to various agents and validating the results before completing the work. And when we use this hierarchical strategy, we need to configure a manager LLM, and that will help to take the right decision. Okay, and you will understand about this sequential or hierarchical strategy when we implement the applications, right? And the next one is agent. So an agent is like a team member with a specific role and goal to perform various tasks and will have access to various tools to execute these tasks, right? So an agent is nothing but an LLM which has its own intelligence because it has been trained, it has tool access, it has domain data, that is RAG, and it has memory which will do a specific task that we assign. And agents interacting with each other is called a process. So an agent is like a team member in the crew with a specific role, background story, goal, and memory. And the agent is the core performer of the tasks assigned within the framework, right? And each CrewAI agent is a LangChain agent because this CrewAI is built on top of LangChain, right? And the next one is task. So task defines the specific work task that needs to be executed. So task, as the name suggests, is the specific task that needs to be executed by an agent. And an agent will perform the task that is assigned. we provide various tools that are required to execute a task. For example, fire crawl, get the API key and crawl the web page, or go to Microsoft and download an email, etc. Right? So those are different tasks. And what is tool? Tool defines an external utility or tool that can be used to integrate with external system to execute a task. These are LangChain tools. So a tool object is a utility or equipment that the agents use to perform a specific task efficiently. For example, searching the web or loading the documents and reading them, etc. Right? And like I said, CrewAI is built on top of LangChain. So we can use any existing ones from LangChain, or we can write our own custom tools as well. So tool is nothing but providing third-party tool access to an LLM. And what is memory system? Memory is nothing but being able to remember the context by an LLM. And what is crew? Think of the crew as a team of agents working together to achieve a particular goal. And these agents have a clearly defined way to collaborate to achieve the set of tasks that are assigned. Crew means combining multiple agents, and each agent will be assigned to do a particular task. And this is for single agent, right? And multi-agent means every single agent will have all these components. Each agent will be assigned to do a particular task, and each agent will be provided by tool access. It will have its own LLM, and each agent will have its own memory, right? So that is nothing but multi-agent. And if you want to go through the documentation in detail, let me take you to the CrewAI documentation. So this is the official CrewAI documentation where you can see different core concepts here. Agents, what is an agent, what is a task, what are crews, flows, knowledge, LLMs, processes, memory, planning, testing, etc. Right? So they have very good documentation here. So if you are interested, you can go through this official CrewAI documentation. All right. Thank you. So we have seen different components of crew, process, agent, task, tool, memory system. So these are different components inside a crew. And now let me show the tools that CrewAI offers, right? So let's go to the official documentation page of CrewAI tools. So this is the official CrewAI tools documentation. And if you see here, you can learn more about tools, right? We have what is a tool, what are the key characteristics of tool, and using CrewAI tools. So here you can see the detailed explanation of each tool. So these are different tools provided by CrewAI. Apify Actors tool, a tool that integrates Apify Actors with your workflows for web scraping and automation tasks, right? So you can use Apify and you can do the web scraping, and you can also automate tasks. And the next one is browser-based load tool, a tool for interacting with and extracting data from web browsers. And code docs search tool, this is a RAG tool. And code interpreter tool, right? CVS search tool, DALI tool, file read, fire crawl. So you can see we have several RAG tools available. JSON search tool, PDF search tool, vision tool, RAG tool, YouTube channel search tool, a RAG tool for searching within YouTube channels, useful for video content analysis. YouTube video search tool, a RAG tool aimed at searching within YouTube videos, ideal for video data extraction. So you can see these are the different tools provided by CrewAI, right? And if you want to create your own tools, you can do that as well by subclassing with base tool, and we will see the implementation. Then you will understand much better. And conclusion, right? So this is the official CrewAI tools documentation. And you know CrewAI is built on top of LangChain, right? So any tool that's provided by LangChain, you can use it in CrewAI too. For example, let me take you to the official LangChain tools documentation. So if you see here, this is from LangChain, right? and you can go through all the different tools that are provided by LangChain, right? For example, Bing search, and this is a paid tool. Brave search, this is a free tool. And DuckDuckGo search, this is also free, right? And Google search is paid. Google Serper is free. By using Serper API, you can do 100 free searches per month, and it will give you the answer as the response, right? So these are the different tools that are provided by LangChain. And you can see the tool or toolkits for code interpreter, right? The following table shows tools that can be used as code interpreters. And these are some of the productivity tools and web browsing tools. And these are used to automate tasks in databases and finance. And these are all the different tools. For example, if you see Epify Actor, Epify Actors are cloud programs designed for a wide range of web scraping, right? So let's go here. So you can go to Epify Actors. So you can see here, you can learn how to develop, run, and share serverless cloud programs. Create your own web scraping and automation tools and publish them on the Epify platform, right? So if you go to the store, you can see, so these are the different actors: website content crawler, Google Maps scraper, Instagram scraper. Scrape and download Instagram posts, profiles, places, hashtags, photos, and comments, right? So these are the different tools that are provided by Epify, right? So there are so many tools that are provided by LangChain. Bing search, Brave search, ChatGPT plugins, and so on. So you have so many tools available inside this LangChain tools documentation. So you can go through at your convenience. So here every single tool has been explained with examples. So depending on your requirement, you can go through these tools to incorporate them when building generative AI applications, right? And we have so many tools, so you just get the key and make use of them depending on your requirement, right? So we went through different components of Crew, that is process, agent, task, tool, and memory system, right? And next thing is, let's see how we can build generative AI multi-agentic applications by using these different CrewAI components. All right, thank you. So we have learned different components of Crew, that is process, agent, task, tool, and memory system, right? So these are the different components of Crew. Now let's build a generative AI application by using CrewAI, and we will use these different components of Crew, right? So let's go to VS Code and try to build an agentic application by using CrewAI framework. All right. So this is our VS Code build generative AI applications workspace, and we have seen RAG demo, that is how to build a RAG application, and we have seen different chunking methods, and then we have seen prompt engineering techniques and how to load the documents by using document loaders, and we have also learned how to give memory to an LLM so it can remember the context, and chains, how to bind an LLM with different LangChain components by using chains, right? So we have seen all these different LangChain components, and now let's see tools and agents. So if you notice here inside the C drive, I have created an empty folder, tools and agents demo. So now let's add this tools and agents demo folder to our VS Code workspace. So right click, add folder to workspace, and select the folder that we have created and click add, click S. Now inside the tools and agents demo, let's create a new Python file, and we will be scraping a website. So let's go to tools and agents demo, and inside that CrewAI use case 1, and we are building a web scraping application, and click save. Okay, so in order to use CrewAI framework and also CrewAI tools, first thing is we have to install all the required packages, right? So we know by using pip install CrewAI and pip install CrewAI tools. So if you don't know the exact package name, you can always go to PyPy and get the exact package name, right? So you have to install CrewAI and CrewAI tools. So copy this and go to the terminal and execute this one. Pip install CrewAI. In my case, I've already installed, so that's why it is showing requirement already satisfied. And similarly, copy this and hit enter, right? So that way these two packages will be installed. So make sure you install CrewAI and CrewAI tools. So once you install these required packages, the next thing is we have to import the required modules. So let me close this and also this. So what we are doing here, we are trying to import scrape website tool and text search tool. These two modules from CrewAI tools, and also we are trying to import agent, task and crew. These three from CrewAI and OS module. Now let's use this scrape website tool and try to scrape a Wikipedia page. So here we are trying to use scrape website tool, and inside that we have website underscore URL parameter, and we are trying to pass the Wikipedia page. Instead of this, you can replace with any other website, and this tool will scrape the data and it will give us the data, right? So that is the intent of using this scrape website tool. So let me add that comment here. We are trying to scrape Wikipedia website by using CrewAI tool, which is nothing but scrape website tool. And inside this scrape website tool, we have a function called run. So let's try to extract the text by calling the run method, which is inside scrape website tool. So we are calling the run method and we are extracting the text. So let me save this and let's go to the terminal. So now let's try to run this code. So if you notice here, this is the entire content that the tool scraped from this Wikipedia website. Okay, so which is stored inside this text variable. So once you have the data, you can try building different agents and you can assign different tasks. For example, one agent you can assign sentiment analysis, or another agent you can ask to do translation, that is which can translate from one language to another, or another agent can send an email of some of the results, right? So once you have the data, you can try to create different tasks and assign them to different agents, right? Now let's try to store this scraped data inside a text file. So let me close the terminal. So by using this OS module, I am trying to go to the directory. This is ch directory. So this function is used to change the directory. From this directory, I'm going to my documents data folder. So from the current directory, we are going to the documents data directory. So if you see here, this folder is empty. I do not have anything currently. So let's try to save this text by creating a file and store the data inside it. So let's write the content by using file write and store this Wikipedia content, artificial intelligence. So I'm storing as ai.text and we are writing the content. So whatever the text we extracted by using scrape website tool, which is from CrewAI tools, we are trying to store that content inside ai.txt. That's the text file. Okay. So what we did here, we're trying to store the scraped data into a text file ai.txt. And now we also have this text search tool. By using this text search tool, which is from CrewAI tools, let's retrieve the specific context that we want. Okay. So text search tool, and we are passing for the text attribute, I'm passing this file name. Inside this file we have our extracted data, and let's pass a question. Inside this text search tool we have a method called run, and for that we are passing what is natural language processing, right? NLP. So this is the desired content that we want. So what we did here, we are trying to use text search tool and trying to retrieve the specific context that we want from this AI.txt file, right? Out of this artificial intelligence content, we only want natural language processing context, right? So we got our context which is saved inside a context variable. So what we have done so far, we have installed all the required packages. First one is CrewAI and the next one is CrewAI tools. From CrewAI tools, we imported scrape website tool and text search tool, and from CrewAI we imported agent, task and crew, and this is the OS module. And the first thing is we used scrape website tool, and for website URL parameter we passed our website. Here instead of Wikipedia page you can replace with any other website, and by using this scrape website tool we scraped the website, and inside scrape website tool we have a method called run, and we called that method and we extracted the text and we stored inside a variable called text. And next thing is we changed our directory to documents data, and we wrote the content from this variable to a file, and then once we wrote the content inside this text file, next thing is we used text search tool and we passed our file name to this text attribute, and inside the text search tool we have a function called run, and here we are passing a specific context that we want. Out of this artificial intelligence text, we only want the context that is related to NLP, natural language processing, and we are storing our context inside a variable called context. Okay, so this is our desired context. So now we got the data which is stored inside our context variable. So once you have the data, the next step is, let's see how to build a multi-agentic framework by using this CrewAI, right? So we imported agent, task and crew. So in order to build a multi-agentic framework by using CrewAI, we need to define agents, task and crew. So inside the agent, we will have role, goal and backstory. And let me show the detailed description of agents. So this is the official agents documentation from CrewAI. This is the overview of an agent and what are the agent attributes. So you can see the complete attributes list inside an agent, right? So if you go here, role, goal and backstory, these are the required parameters. So what is role? Defines the agent's function and expertise within the crew. Goal means the individual objective that guides the agent's decision making. Backstory means provides context and personality to the agent, enriching interactions, right? So that is role means what the agent will do. Goal means more descriptive on what the agent will do. Backstory means complete description, right? And the LLM, which model the agent will use. So that is nothing but the LLM, and this is optional. And tools is also optional, and tools means if agent needs any tool access, right? And similarly function calling LLM and max iterations, max RPM. RPM means request per minute, right? This is to avoid the rate limit, and this is also optional. And max execution time, this is also optional, and memory is also optional, right? So by default agent will have some memory. So the next thing is verbose. Verbose is also optional. We've already seen this verbose is equal to true. That means it will give us the complete or detailed execution logs whenever we specify verbose is equal to true, so that we can see the complete output in the terminal, right? And allow delegation, by default it is optional, and if you give allow delegation is equal to true, it will try to delegate the tasks among different agents, right? And step callback, cache, allow code execution, max retry limit, by default it is optional. That is how many times the LLM should try. For example, let's say if you're trying to do the web crawling, right? How many attempts the LLM should try before it exits, right? And respect context window, code execution mode, use system prompt, etc., right? So you can go through all other parameters depending on your requirement. So This is how we have to create an agent. So total 3 steps. So the first step is creating agents. Second step is creating the task so that we can assign a task to an agent, and then we have to create the crew. So these are the 3 steps in order to build a multi-agentic framework by using CrewAI. Okay. So let's try to create one by one. The first step is create an agent. So we are trying to create an agent. So if you notice here, we are using agent which we imported from CrewAI, right? So inside this agent, we are passing these parameters. Role as educator, goal based on the context provided. We have already stored our context inside this context variable. So based on the context provided, answer the question, what is natural language processing context? And we are passing this dynamic variable. And backstory is you are a data expert. Verbose is equal to true. So that means it will give us the complete execution log in the terminal. And allow delegation is equal to false because we will be creating only one agent. So that's why we give allow delegation is equal to false. And let's say if you have multiple agents, then you can give allow delegation is equal to true. So that way one agent can communicate with another agent. And for tools, we are passing this list, the tools list, which we have already defined before. So this is how you can create an agent. So that is step number 1. So if you notice here, this role, goal and backstory, this is nothing but prompt engineering, right? We have already seen this before. So this is how you can create an agent. And the next step is creating the task. Okay. So how do we define a task? By using task, which we have imported from CrewAI, right? So inside the task, we have to pass these parameters. Description, what this task will do, understand the topic and give the correct response. And tools, we are passing the tool list. And agent, we have to assign this task to an agent, right? And the agent we have already created, and we assigned a variable name data analyst, right? So this is our agent. So we are assigning this task to an agent, and the expected output is give a correct response, right? So you try to understand the context and you answer the question, what is natural language processing, right? So far we have created an agent, data analyst agent, and we created a task and we assigned this task to data analyst agent. So step number 1, creating agent. Step number 2, creating the task. And the next step is creating the crew. So let's create the crew. So how do we create the crew? We have already imported this crew, which is inside CrewAI. So let's use crew and pass both agent and task. If you have multiple agents, you have to pass them inside this list. And similarly for tasks, if you have multiple tasks, you have to pass them as a list. Okay. So that is how we created our crew. So we have created the agent and then task and then crew. So once you have the crew ready, the next step is we have to run the crew. Okay. So inside the crew, we have a method called kickoff. So by using that, we will run the crew. And we are trying to store the results inside a variable called output. And now let's try to print the results, output.raw. Okay. Now let's save this file and let's try to execute the code. So let me comment this print statement. And now either you can kill the terminal or you can just clear the session. And now let's try to rerun the code. Okay. So let's see the output and try to understand what it has given for us. So this is the complete output. We are seeing this complete output because we gave verbose is equal to true, right? So that is why it is trying to give us the detailed execution log. So you can see here thought, I now can have a great answer. Your final answer must be the great and the most complete as possible. It must be outcome described, and this is the educator agent. So that is what we have created here, right? And what is the thought? I need to conduct a search for the definition and explanation of NLP in the provided context and using the tool. This is the tool I'm using, and for that tool I'm passing this as the input and I'm trying to search, right? So it is trying to search, and you can see the complete detailed execution log here, and finally it reached the maximum iterations. So if you scroll down all the way, you can see maximum iterations reached, requesting the final answer, and the final answer is natural language processing. NLP is a subfield of artificial intelligence that focuses on the interaction between computers and humans through natural language, right? So it gave us the complete answer. So here we are trying to print this output, and also we are trying to print this, so that's why we are seeing it twice. So let me close this and let me try to explain real quick what we did here. So the first thing is we try to install the required packages CrewAI and also CrewAI tools. So from CrewAI tools we try to import scrape website tool and text search tool, and from CrewAI we imported agent, task and crew, and we also imported OS module. And the first one is we used scrape website tool and we passed our website that we want our tool to scrape, and inside the scrape website tool we have a method called run, and we called the run method and we stored our scraped data inside a variable called text. Whatever the data we extracted, we are trying to write that to a file called AI, and we are trying to store that inside documents data folder. And then the next step is we are using this text search tool and we are passing this file name so that we can get our desired context. Here out of artificial intelligence, we are only interested in NLP, natural language processing. So that is our context. So inside the text search tool, we have a method called run and we are passing this so that we will get the context, and we are storing that inside a variable called context. And in order to build a multi-agentic framework by using CrewAI, we have to create agent, task and crew. So how do we create an agent? By using this, we have to pass all these parameters: role, goal and backstory. So this is nothing but prompt engineering. Verbose is equal to true means it will give us the complete execution log. Allow delegation is equal to false. If you want multiple agents to delegate the work to each other, then you give allow delegation is equal to true, and the tools which we have defined already. So we have created our agent, and the next step is creating the task. How do we create the task? By using this task, we are passing these values: for description, understand the topic and give the correct response. And then for tool, whatever the tool we have defined, we are assigning that to tools. And the agent, we have already created an agent, we assign that to an agent, and the expected output is give a correct response. And the next step is creating the crew. Once we created the agent and the task, the next step is creating the crew and assigning the agents. This is the agent list. For task, we are assigning the task list. And once we have the crew, next step is running the crew by calling the kickoff method which is inside crew. So that will give us the output of the specific task, right? So this is how you can build an agentic framework by using CrewAI, right? So we only have like 3 steps here: creating an agent, creating a task, creating the crew, and then running the crew. Here we have only created one agent, but in the next lecture we will see how we can create multiple agents and multiple tasks and how we can assign multiple tasks to multiple agents, and how we can build a multi-agentic framework by using this CrewAI. Alright, thank you. So far we learned different components of Crew, that is process, agent, task, tool and memory. Right, so these are the different components of Crew, and we built an agentic framework by using this CrewAI. So let's go to VS Code and see another use case. So in the previous lecture, we learned how to build this use case by using CrewAI. So we scraped this Wikipedia website by using scrape website tool, which is from CrewAI tools. And then the next thing is we extracted the text, and we were interested in natural language processing. So we extracted the text and we stored inside the context variable. And in order to build a agentic framework by using CrewAI, first thing is we created an agent by instantiating this agent class and passed all these parameters: role, goal and backstory. These are nothing but prompt engineering, right? And the next thing is we created the task by instantiating this task class, which is again from CrewAI. And then the next thing is we created the crew by instantiating crew class, which is again from CrewAI. And then we ran the crew by calling the kickoff method, which is inside this crew class, right? So that is how we were able to build an agentic framework by using CrewAI. And here, if you notice, we have only created one agent. So now let's see another use case where we can build multiple agents by using CrewAI. Okay, so let me click on this and create a new Python file. And let me save this as CrewAI use case 2, personalized email drafts, and click save. So here we are trying to build a multi-agentic framework for personalized email drafts by using CrewAI. So the first thing is make sure you install all the required packages, that is CrewAI and also CrewAI tools. In case if you haven't installed already, make sure you install them by going to the terminal and executing these commands. Okay. And the next thing is we have to import all the required modules from CrewAI and also CrewAI tools. And if you notice here, we are importing agent, task and crew from CrewAI, and directory read tool, file read tool and serper-dev tool, these three tools from CrewAI tools, and also base tool again from CrewAI tools, and load.env and OS modules. So I will explain all these in detail when we are trying to use them. So here we will be using serper-dev tool as our search tool. So let me show you first how to get the API key from serper-dev and how we can store that inside an environment file. So this is the website where you have to go, serper.dev, and click on sign up, and make sure you create an account here. Provide your first name, last name, email, password, and click on create account. Okay. So once you create an account, then click on login, and you will see a page similar to this. So here you have dashboard, playground, API key, logs, billing, right? So click on API key and copy this key. So that is how you can get the serper-dev API key. Okay. So serper-dev offers free credits when you create an account. So make sure you use the free credits before you buy more credits, right? So in case if you want to buy credits, you can click on billing and provide your details and you can buy more credits. Okay, so that is how you will get the key. And inside our tools and agents demo folder, let me create a new file and let's save this as .env, and let's try to save this as serper API key, and here you have to store your API key. Okay, so make sure you get the key and replace here. And we will be using OpenAI as our LLM. So we have already seen how to get the API key from OpenAI, right? So make sure you store your serper API key here, and also for OpenAI API key here. Replace serper API key here and also replace OpenAI API key here. Okay. And in case if you do not want to pay for serper, once you use all the free credits, then you can always choose any other open source search tool. For example, if you see DuckDuckGo, so this is a open source search tool. Instead of serper tool, you can always use a open source search tool like DuckDuckGo. Okay. So once you get both serper-dev and also OpenAI API keys, make sure you save them inside this environment file. And now let's try to set the API keys. So the first thing is, by using this load_.env function, let's try to load the environment variables from this .env file by using this load_.env function, which is from .env. And then the next thing is, let's try to read the API keys. So inside OS module, we have a function called getEnv, and we are calling this function and passing the name, right? So once you pass the name, we will get the value. That is our OpenAI API key. Similarly, for Serper API key, we are passing the name and we will get the value. So we stored our API keys with these names inside this env file. And now once you get the API keys, let's try to store them inside the environment variable OpenAI API key and also Serper API key. So in order to build a multi-agentic framework by using CrewAI, we know we have to create an agent, task, and crew. So first thing is, let's try to create an agent. So let me close this. So the first thing is, let's try to create an agent by instantiating this agent class, which is from CrewAI, right? And here we are passing these parameters: role, goal, backstory. This is nothing but prompt engineering, and allow delegation is equal to false. We do not want to delegate the tasks among agents, and verbose is equal to true. You know, if we give verbose is equal to true, we can see the complete execution log. And what is the role of this agent? It is a sales representative agent. And what is the goal of this agent? Identify high value leads that match our ideal customer profile. And what is the backstory? As a part of the dynamic sales team at ABC company, your mission is to score the digital landscape for potential leads. Armed with cutting edge tools and a strategic mindset, you analyze data, trends, and interactions to unearth opportunities that others might overlook. Your work is crucial in paving the way for meaningful engagements and driving the company's growth, right? So this is the context we are providing inside backstory. So that is how we created our sales representative agent. So that is agent number 1. And now let's create one other agent, and this is lead sales representative, right? Again, we are setting these parameters: role, goal, backstory, allow delegation, and verbose. And role is lead sales representative. Your goal is, as a lead sales representative, your goal is to nurture leads with personalized, compelling communications. And what is the backstory? We are providing some context. Within the vibrant ecosystem of ABC's sales department, you stand out as the bridge between potential clients and the solutions they need. By creating engaging, personalized messages, you not only inform leads about our offerings, but also make them feel seen and heard. Your role is pivotal in converting interest into action, guiding leads through the journey from curiosity to commitment. So that is the role of this lead sales representative agent. So we have created two agents. One is sales rep agent, the other one is lead sales rep agent. And now let's create the tools. So here we have imported the tools from CrewAI tools: directory read tool, file read tool, and Serper dev tool, right? So let's make use of them. So the first one is, we are using directory read tool. So we instantiated this class and we passed the directory name. And the next one is file read tool, right? So by using this, we can read the file. And then let's instantiate Serper dev tool as well. This is our search tool. All these three tools are from CrewAI tools. Okay. And now, in addition to these CrewAI tools, in case if you want to create your own custom tool, you can do that as well by extending the base tool class. So how can we create a custom tool? So let's see how we can create a custom tool by using CrewAI's base tool, which is again from CrewAI tools. Okay, so let me create a custom tool, which is nothing but sentiment analysis tool, and we are extending with base tool, which is again from CrewAI tools, right? And every tool needs to have a name and a description. Okay, Here we are giving the name as sentiment analysis tool, and description analyzes the sentiment of text, that is either positive or negative, to ensure positive and engaging communication. And here goes your any business logic that you want to implement. So this is how you can create a custom tool by extending this base tool. So now let's instantiate this custom tool as well. Sentiment analysis tool, right? So that is how you can create a custom tool. And now once we have these agents, let's assign tasks to these agents. So let's create the tasks. The first task is so this is our task number 1. And we are assigning this task to sales rep agent. And we are instantiating this task class, and we are creating this task by setting these parameters, right? So description, expected output, tools, and agent. So what is the description of this task? Conduct an in-depth analysis of lead name. We will pass this lead name when we call a company in the industry. This is again a dynamic variable in the industry sector that recently showed interest in our solutions. Utilize all available data sources to compile a detailed profile focusing on key decision makers, recent business developments, and potential needs that align with our offerings. This task is crucial for tailoring our engagement strategy effectively. Don't make assumptions and only use information you are absolutely sure about. Okay. And what is the expected output out of this task? A comprehensive report on lead name, including company background, key personnel, recent milestones, and identified needs. Highlight potential areas where our solutions can provide value and suggest personalized engagement strategies. And what are the tools that this task can utilize? Directory retool, file retool, and search tool. All these tools we have already defined here. To whom we are assigning this task? To sales rep agent, which we have already created, right? So that is how we created our task number 1, and we assign that task to sales rep agent. And now let's try to create another task. So here personalized outreach task, and we are instantiating the task class, and here we are setting these parameters: description, expected output, tools, and agent. If you notice under tools, we are passing sentiment analysis tool, which is nothing but the custom tool that we have created by extending base tool, right? So this is our sentiment analysis tool which we have created by extending base tool. So the personalized outreach task is using our custom tool, which is nothing but sentiment analysis tool, as well as CrewAI tool. This is SerperDev tool, right? So let me add that comment here. And then again we are setting these parameters: brief description on what this task should do, and what is the expected output, and what are the tools to use in order to perform the task, and what is the agent, right? So what is the description here? For the personalized outreach task, using the insights gathered from the lead profiling report on lead name, craft a personalized outreach campaign aimed at key decision maker, the position of lead name. So all these parameters are dynamic variables, right? So we will pass these values when we call them. The campaign should address their recent milestone and how our solutions can support their goals. Your communication must resonate with lead name's company culture and values, demonstrating a deep understanding of their business and needs. Don't make assumptions and only use the information you are absolutely sure about. And what is the expected output? A series of personalized email drafts tailored to lead name, specifically targeting key decision maker. Each draft should include a compelling narrative that connects our solutions with their recent achievements and future goals. Ensure that tone is engaging, professional, and aligned with lead name's corporate identity. Okay, so this is the expected output. So we are trying to generate personalized email drafts. And these are the tools that we are passing. Sentiment analysis tool, this is our custom tool that we have created by extending the base tool. And this search tool is nothing but the SerperDev tool. And we assigned this task to lead sales representative agent. So far we have created the agents, and then we created the custom tool, and we also created the tasks, right? And now let's create the crew. Okay. So we can create a crew by instantiating this Crew class, which is from CrewAI, right? And here we are setting these parameters. For agents, we are passing the agent list. So we created two agents, sales rep agent and also lead sales rep agent. So we are passing this list, and for tasks, we are passing this list, lead profiling task and also personalized outreach task. And verbose is equal to true. So that means give the complete execution log, and memory is equal to true. So make sure you remember the context. And the next thing is, once we created the crew, let's try to run this crew. So if you notice here, we are using all these dynamic variables, right? So we need to set values to all these variables. So first let's try to set values to all these dynamic variables, right? So lead name, wherever it says lead name, it will replace with AI with Mala. And industry is online learning platform. Key decision maker Mala H, and position is CEO, and milestone is product launch, right? So we have set our input data. Now once we have the data ready, let's try to run the crew by calling kickoff method, which is inside crew, right? And for the inputs attribute, we are passing whatever the inputs that we set here. So once you run the crew, now we have the results here. Let's try to display the final result as the markdown. So here we are trying to display the final result as markdown. So from IPython display, we are trying to import markdown module. So let me put that here. And then here we are trying to print the results as markdown, right? So let's try to save this code and run it. So you can see crew execution started, and the agents are trying to perform different tasks. And the sales representative task is to provide a comprehensive report on the specified lead name, right? And then once we have the report ready, the next step is creating the personalized email draft by another task, that is personalized outreach task. So both sales rep agent and lead sales rep agent, they both are trying to perform the task, and let's see if we will get the personalized email draft at the end. So let's try to understand this output. So this is the result. So if you see the output, this is the personalized email draft that is generated by this lead sales representative. So what is the final answer? Hi Mala, I hope this message finds you well. Congratulations to you and your team at AI with Mala. So this is the company name, on your recent product launch. It's truly exciting to see innovative educational solutions entering the market. As the online learning environment continues to evolve, I believe our AI-driven engagement solutions could greatly enhance user experiences on your platform. We focus on leveraging AI to foster learner interaction and personalization, which I feel aligns perfectly with your goals at AI with Mala. I would love to set up a brief call to discuss how we can support your mission and the success of your new offering. Would next week work for you? Looking forward to your response. Best regards, and your name, right? So this is our personalized email that is generated by this lead sales representative, right? So here you can see the complete detailed execution log, because we have given verbose is equal to true. So that is the reason it is trying to give us the complete execution log. So here you can see the crew execution started, and it is trying to perform these tasks. And first thing is, the sales representative agent is trying to conduct an in-depth analysis on this company AI with Mala, and it is trying to generate the report by gathering all the information about that company. And once we have the report ready, the next step is lead sales representative is trying to draft a personalized email, right? So that is the intent of using this multi-agentic framework. So instead of these tasks, you can replace with your own project scenarios and see if you are getting the desired output or not. For example, let's say if you want to send a broadcast messages to all your contacts, right? Then you replace this description and expected output accordingly, right? So you can use your own scenarios or applications as well, right? Instead of these tasks, try to replace these tasks with your own project scenarios and see how it is working, right? So let's quickly go through what we have learned here. So we are trying to build a multi-agentic framework by using CrewAI. The first thing is we try to install CrewAI and also CrewAI tools. We imported agent, task and crew. In order to build a multi-agentic framework, we need these classes which are imported from CrewAI. And then the next thing is we imported all the tools that are required from CrewAI tools and also the base tool again from CrewAI tools and load environment variable. And this is to display the results in markdown format. We imported this and the OS module. The first thing is we try to set the API keys. In our application, we are not using OpenAI API key, so you don't have to set this. We are only using Serper API key. So make sure you set this API key. We are creating the agents. We created sales rep agent and also lead sales rep agent, and we are instantiating the agent class and we are setting these parameters: role, goal, backstory, allow delegation and verbose, right? So this is nothing but your prompt engineering. So what is the role of this agent? What is the goal of this agent? And what is the short description that the agent should do, right? And the allow delegation, if you want to delegate the task to different agents, then you set this to true. Otherwise, you can set this as false. And verbose is equal to true means it will give the complete execution log whenever this agent is trying to execute. And then we created another agent, lead sales rep agent. And again, we are setting these parameters: role, goal, backstory, and the allow delegation is equal to false and verbose is equal to true. And then we created our own custom tool by extending CrewAI tools base tool, right? And this is the class name, and we have to set these parameters: name and description. And here you can define your own custom logic inside this method, right? And here we are trying to instantiate our custom tool, right? So this is how you can create your custom tool. And if you notice, we are using CrewAI tools as well: directory read tool, file read tool, and Serper dev tool. This is the search tool, this is for file reading, and this is the directory read tool. And then the next step is we created the tasks. We created two agents and we need to assign task for those two agents. The first one is lead profiling task, and we assigned this to sales rep agent. And this is the description of the task and what is the expected output of the task. And the tools that the agent should do when performing these tasks are directory read tool, file read tool, and search tool. And we assigned that to sales rep agent. And then we created another task, personalized outreach task. And what is the expected output of this task? To generate a report on the company name, right? And then we created another task, personalized outreach task, and we passed again these parameters: description, the short description on this task, and what is the expected output. The expected output is to generate a personalized email draft. So instead of these, you can replace with your own project scenarios and see how it is generating, right? And for tools, you can use sentiment analysis tools. So this is the custom tool that we have created, and also Serper dev tool, which is the search tool, right? And we assigned this task to lead sales rep agent. So far we have created the agents, tools, and then tasks. Next step is creating the crew by instantiating crew class, and we are setting these parameters. For agents, we are passing the agents list. For task, we are passing the task list, and verbose is equal to true. We want to see the complete execution log whenever this crew runs, and memory is equal to true. And here we are trying to set the input data. So what is the lead name, industry, key decision maker, position, and milestone. Once we set the input data, the next step is we are trying to run the crew by calling the kickoff method and passing our input data. So here we are trying to print the final results as markdown, right? So that is how you can create a multi-agentic framework. So instead of these scenarios, you can try to replace with your own project scenarios and see how you can build different multi-agentic frameworks by using this CrewAI. Alright. And I also want to show you one other thing here. In case if you want to stay updated on the AI news, so you can go to Alpha Signal, right? And then provide your email here and click on Get My Summary. This is free. So you will get all the updated news from AI, right? So instead of you going through different emails or different websites and trying to understand what is happening in the AI world, so you can just provide your email and click on Get My Summary. So this will give you a daily 5-minute email summary of the latest breakthrough news, models, papers and repos, right? So this is free. You can make use of this alpha signal, right? So that's all about creating a multi-agentic framework by using CrewAI. So far we have seen web scraping and also how to do personalized email draft. All right. Thank you. So we have seen different components of Crew, that is process, agent, task, tool and memory, right? And we built multi-agentic applications by using this CrewAI, right? Now let's go to VS Code and see another application. So far we have seen one of the scenario, web scraping and extracting the text and then creating the agent and task and running the crew and retrieving the desired results. And then we have seen another application where the agents were able to generate the personalized email drafts, right? So now let's see another use case number 3. So let me go to tools and agents demo and file, new file and Python file, and let me save this as CrewAI use case 3 trading platform and click save. So let's see how we can build the complete stock trading platform project demo by using CrewAI. Okay, so the first thing is we need to install all the required packages before we start building the application. And we know we have to install CrewAI and also CrewAI tools. In case if you haven't installed already, make sure you install these two packages by going to the terminal and giving this command and hit enter. So that way these two packages will be installed. And for this application we also need tokenizers. This is the latest version of tokenizers we need. In case if you haven't installed already, make sure to install this latest version of the tokenizers as well. So I will explain why we need these packages, right, when we start using them. And the next step is we have to import all the required modules from these packages. So here we are trying to import agent, task and crew classes from CrewAI package, and then scrape website tool, Serper dev tool from CrewAI tools, and crew and process from CrewAI, and then chat OpenAI from LangChain OpenAI. We will be using OpenAI as our LLM, and then load.env from .env and OS module. So these are the required modules that we need. And once we imported all the modules, now let's try to set the API keys, and you need to store these API keys inside this environment file and read that inside our code. I've already shown you how to store the environment variables inside this environment file. So let's try to load the environment variables from this .env file by using load_.env function, which is from .env package. And the next thing is let's try to read the API keys once we load the environment variables from this environment file. So we have stored our OpenAI API key and also Serper API key. These two are stored inside this environment file. So this is the name and the value we have stored inside this. So by using this OS module and using the getEnv function, we are passing the name, so we will get the value. So that is how we read both OpenAI API key and also Serper API key. Let's try to store these two API keys inside the environment variables, OpenAI API key and also Serper API key. And here we will be using both scrape website tool and Serper dev tool. So let's try to instantiate both these tools. So Serper dev tool is our search tool, and to scrape the website we will be using scrape website tool. So let's instantiate that as well. So here Serper dev tool is the search tool, so we are assigning to this variable, and scrape website tool is used to scrape the website. So these two tools, we are using them from the CrewAI tools. One is the search tool and the other one is a scrape tool. We have already seen how to get the API key for Serper Dev tool in the previous lecture. So make sure you get the key and store it inside the environment variables and then read the API keys here. Okay. Instead of using Serper Dev as our search tool, in case if you want to use any other open source tool like DuckDuckGo, you are welcome to use that as well, right? So you don't have to use just the Serper Dev tool. You can explore any other tools also. And let me close this. So far we have installed all the required packages and then we loaded the modules and then we read the API keys and then we stored inside our environment variables both OpenAI API key and also Serper API key, and then we instantiated both tools from CrewAI tools. One is the Serper Dev tool, that is the search tool, and then the next one is the scrape website tool, right? And now by using this agent, task and crew classes, let's try to create agent, task and crew, right? So the first thing is, in order to build the multi-agentic framework, we need to create the agents. So let's try to define an agent by instantiating this agent class, which is from CrewAI. So here we are trying to define the data analyst agent. Here we are instantiating this agent class and we are setting these parameters. For role, we are setting as data analyst. And what is the goal of this agent? Monitor and analyze market data in real time to identify trends and predict market movements. And what is the backstory? Specializing in financial markets, this agent uses statistical modeling and machine learning to provide crucial insights. With a knack for data, the data analyst agent is the cornerstone for informing trading decisions, and verbose is equal to true. So that means we want to see the complete execution log whenever this agent is trying to perform any task, and allow delegation is equal to true. So that means the agents will try to delegate the task with another agents, and tools is equal to, here we are passing the tools as a list, so we are using both scrape tool and also search tool. So this is how we created data analyst agent. So that is our agent number 1. So you know, role, goal and backstory, these three are nothing but prompt engineering, right? So here we are trying to provide the context, right? So we are saying, as a data analyst, your goal is this and this is your backstory, right? So that is, we are trying to provide more backstory or context, right? So these three things, role, goal and backstory, are mandatory whenever we are trying to create an agent, and verbose is optional, and allow delegation, that is to delegate to other agents, and the default value is false, but we are trying to set it as true. So the agents can delegate the tasks to another agents, right? And we haven't written memory here, but the default value of memory is true, right? But the objective of this agent is just to collect the data. We don't need memory anyways here, right? And we have specified these tools as well, both scrape and search tool. So with this agent, the data analyst agent, has tools, memory, and we will assign the task as well, right? So the agent will know what to do. So this is one agent which does data collection, right? And now let's create another agent, agent number 2. So this is the trading strategy developer. The first one is data analyst. The second one is trading strategy developer. And what is the goal? Develop and test various trading strategies based on insights from the data analyst agent. So the data analyst will give you the report, and based on the insights, you give us the trading strategies. So this one will give us the insights and this one will give us the trading strategies. And what is the backstory? Equipped with a deep understanding of financial markets and quantitative analysis, this agent devises and refines trading strategies. It evaluates the performance of different approaches to determine the most profitable and risk-averse options. And verbose is equal to true, allow delegation is equal to true. And again, we are passing scrape tool and search tool as our tools, right? So this is the trading strategy developer agent. So far we have created 2 agents, and this trading strategy agent is dependent on data analyst agent, because first the data analyst agent has to analyze the data and identify the trends, and then the role of trading strategy developer is to develop the trading strategies based on the insights from data analyst agent. So this agent is dependent on this agent, right? So these 2 agents have to work in sequential order. That is, the output of data analyst agent will be the input to trading strategy agent, right? And this process is nothing but sequential. So the objective of data analyst agent is to identify trends and predict market movements, and the objective of trading strategy agent is to create the strategy, right? So far we have created 2 agents, and now let's create another agent. So let's try to define the third agent. This is trade advisor agent. So what is the role, goal, and backstory of this advisor agent? The role is trade advisor. What is the goal? Suggest optimal trade execution strategies based on approved trading strategies. So we will get these trading strategies from trading strategy agent. So once we get the trading strategies, the role of this trade advisor agent is, this agent specializes in analyzing the timing, price, and logistical details of potential trades. By evaluating these factors, it provides well-founded suggestions for when and how trades should be executed to maximize efficiency and adherence to strategy. And verbose is equal to true. We want to see the complete execution log, and also allow delegation is equal to true, and we will be using these 2 tools when executing this task, right? So far we have created 3 agents. Agent number 1 is for the data collection, and agent number 2 is to develop the trading strategy, and agent number 3 acts as a trading advisor, that is to recommend when and how to trade, right? So far we have created 3 agents, and now let's try to create the 4th agent, that is the risk assessment agent. So this is our agent number 4. And what is the role? Risk advisor. And what is the goal? Evaluate and provide insights on the risks associated with the potential trading activities. And what is the backstory? Armed with a deep understanding of risk assessment models and market dynamics, this agent scrutinizes the potential risks of proposed trades. It offers a detailed analysis of risk exposure and suggests safeguards to ensure that trading activities align with the firm's risk tolerance. And verbose is equal to true, allow delegation is equal to true, and again tools, we are using scrape tool and search tool. So far we have defined 4 agents, starting from collecting the real-time data to getting suggestions of which stock to buy and analyzing the risk in case if you buy those stocks, right? The next thing is we have to assign tasks to all these 4 agents, right? So let's try to create the tasks. Okay. And now for these 4 agents, the first one is data analyst agent. So let's try to create the task for this data analyst agent. So we are instantiating this task class, which is from CrewAI, and we are setting these parameters. For description, continuously monitor and analyze market data for the selected stock. This is the dynamic variable. We will be passing the stock name, so that will be replaced here. Use statistical modeling and machine learning to identify trends and predict market movements. So that is the description of this task. And what is the expected output? Insights and alerts about significant market opportunities or threats for the particular stock name, right? And we are assigning this task to data analyst agent, right? So that is our task number 1, which is assigned to data analyst agent. Okay. So here we are not hard coding the stock name. Instead, we are trying to just build a generic trading framework. So you can use this for any stock. It is not just for one stock. You can assign any stock value to this stock selection variable, right? And instead of these prompts, you can replace with any other prompts as well. So you can see the desired output. And also make sure you are providing the correct agent name. Whatever you have defined here, you have to provide the same name for this agent parameter. All right. So now, similarly, what is the second agent? trading strategy agent. So now let's try to create a task for this agent and assign it to this. So that is our task number 2. So here we again instantiated this task class and we are setting these parameters. And what is the description of this strategy development task? Develop and refine trading strategies based on the insights from the data analyst, right? And user defined risk tolerance. We will pass these value, and this is a dynamic variable again. Consider trading preferences. So we will pass the trading strategy preference as well. And what is the expected output of this task? A set of potential trading strategies for the stock name that aligns with the user's risk tolerance. And what is the agent? We want trading strategy agent to perform this task and give us the expected output. Okay. And similarly for the third agent, which is nothing but execution agent. So that is the trade advisor. We need to assign the task. So let's try to create the task and assign that to execution agent. So here again we instantiated this task class and we are setting these values. And what is the description of this task? Analyze approved trading strategies to determine the best execution methods. So we will get these trading strategies from the second agent, right? The output of the second agent is trading strategies. The output of the first agent is to provide the insights. The output of the second agent is to give us the trading strategies. So what is this task doing? Analyze approved trading strategies to determine the best execution methods for the stock. Consider current market conditions and optimal pricing. And what is the output we want? Detailed execution plans suggesting how and when to execute trades for this stock, right? And we are assigning this to execution agent, that is agent number 3, and this is the task number 3. So similarly for the last agent, which is risk advisor agent, let's try to create a task. So that is our task number 4. And what is the description? Evaluate the risks associated with proposed trading strategies and execution plans for the stock. Provide a detailed analysis of potential risks and suggest mitigation strategies, right? And what is the expected output of this task? A comprehensive risk analysis report detailing potential risks and mitigation recommendations for the corresponding stock. And we are assigning this to risk management agent. So far we have created 4 agents and we defined 4 tasks. And we assigned these 4 tasks to 4 agents, right? And the next step is creating the crew. So let's try to define the crew with these 4 agents and 4 tasks, right? So this is our crew. We are instantiating this crew class and we are setting agents, tasks, manager LLM, process and verbose. For agents, we are passing these 4 agents that we have created as a list: data analyst agent, trading strategy agent, execution agent and risk management agent, right? So this is the agents list. And the next one is tasks list. Whatever the tasks that we have created, we are passing them as a list. And this is the manager LLM. So for the LLM, we are using OpenAI, and this is the model we are using, GPT 3.5 Turbo, and temperature is equal to 0.7, and process is equal to, we are following the hierarchical process. So that means it is not sequential, right? So the manager LLM, that will need to approve before you buy any stock, right? And all the agent results will be approved by this LLM. So that is why we are using this manager LLM. And the process class, this one, we have imported from CrewAI, right? So this process class helps to delegate the workflow to the agents. So it is kind of a manager at work, right? So in this example, it is hierarchical process. So we have created the crew. And now before we run the crew, here we are setting few dynamic variables, right? The stock selection and risk tolerance, trading strategy preference. For all these dynamic variables, let's try to set the input data. So this is our example data for kicking off the process, right? Financial trading inputs, these are the values, name value pair. For the stock selection, we are using Apple as our stock. Here instead of this you can replace with any other values. And this is the initial capital, and risk tolerance is medium, and the trading strategy preference is day trading, and news impact consideration is true, right? So this is our input data. And now let's run the crew. So to run the crew, we know inside this crew we have a method called kickoff. So let's try to run the crew by calling the kickoff method and passing this input value. And the inputs is equal to financial trading inputs, which we have defined here. Now let's try to print the results. The final result is equal to, which is stored inside this result variable. So we are just trying to print the results here, right? And in case if you want to display the final result as markdown, so we can do that as well. So we are just trying to give the file name as output.md. So this is the name of the markdown file. So we are trying to store inside this downloads folder, and the file name is output.md. That is a markdown file, and we are just trying to store this result and writing that to this file, right? So with this you are able to see the results in the terminal, and also we are writing the content to this output.md, that is a markdown file. Okay, and let's just try to print. The markdown content has been saved to this file name. And what is the file name? Output.md, and we are storing that inside downloads folder. So now with this we built the multi-agentic framework. Now let's try to run this code and see if it is generating the output. So let's click on run. So you can see the crew execution started, and the crew manager started as well, and the agent also started the task, and the agent data analyst agent is trying to perform the task. So it is trying to analyze the market data. So it is trying to crawl different websites and trying to give us the real-time data. And then the next one is trading strategy developer, that is in progress. That is the agent number 2, and it is completed. And now the crew manager is evaluating the risks, and the crew manager is in progress. The execution completed, and this is the final result. Apple faces significant regulatory and legal risks threatening its high margin services segment, with potential commission cuts impacting profitability. The China heavy supply chain and political pressure to move manufacturing to the US create major macro headwinds and margin risks for Apple. Lack of innovation, slow R&D growth, and delayed AI adoption further weaken Apple's investment case compared to other mega cap techs. Despite a lower share price, Apple's valuation and growth outlook do not justify a buy. A selling rate is maintained for Apple. Markdown content has been saved to this file, right? So we are trying to store the result inside this downloads folder. So this is our output.md, which is nothing but the same result we are storing inside this file, right? Let's try to go through this output. Since we gave where pose is equal to true, we are trying to see the complete execution log. So here you can see the crew execution started, and the crew manager is in progress, and the first agent is data analyst. It is trying to gather current market data for the Apple stock, including historical prices, trading volume, and financial reports. So it is trying to crawl different websites, for example Yahoo Finance, right? And it crawled hundreds of websites here. So you can see investor.apple.com, wsj.com, that is the Wall Street Journal. It is trying to crawl different websites and gather the real-time data. So that is our data analyst agent, and it is giving the final answer. And this is the analysis that it has provided. And then the crew manager is trying to ensure that the team gathers the necessary market data, right? So the crew manager is kind of a manager where it checks the output of each agent before it approves, right? So The agent started and it crawled to different websites and it collected the real-time data. So the output generated by the agents will be evaluated by the crew manager, right? And once the data analyst completes the execution, the next one is preparing the trading strategy by using trading strategy developer, right? I need to gather the most recent data and analysis for Apple to provide a comprehensive assessment of significant market opportunities or threats, right? So that is the task of trading strategy developer, to develop a trading strategy, and it is trying to execute, and this is the final answer for trading strategy developer. So it provided this strategy, right? And then again the crew manager is trying to evaluate, and then the task is completed. And it also analyzed the risk, and it is finally giving us the output, right? So here you can see risks of trading strategies for Apple. So it is trying to evaluate the risks also. Once it analyzed everything, it is trying to give us the final answer whether to buy Apple stock or not, right? And the crew execution completed, and it is giving the final output, and we are also storing that inside this output as markdown file. So you can see, instead of we searching hundreds of pages and trying to analyze the data and understand the risks, we built a multi-agentic framework and we were able to get the final insight, right? So if you want to go through these websites and trying to understand the results, it might take time, right? So instead of that, we built an agent and we provided the context and we got the analysis of the stock, right? So you do not have to do these tasks manually, right? And the agents are doing it for us. So this is how you can build a stock trading project by using CrewAI, right? So we want suggestions and risks as the output, and which we got from this CrewAI, right? So agents are searching hundreds of pages and providing you with trading insights, right? So which is cool. So now let me close this and let's quickly review what we have learned here. So the first thing is we installed the required packages, that is CrewAI, CrewAI tools and tokenizers. And the next thing is we imported these modules from CrewAI, CrewAI tools and LangChain OpenAI. Here we are using OpenAI as our LLM, and these are to load the environment variables, right? So we read the API keys and we stored inside these environment variables. And then the next step is, here we instantiated our search tool. We are using SerperDev as our search tool and Scrape website tool as our scrape tool, because it is trying to crawl different websites. As we saw in the output, it tried to crawl hundreds of websites and provide us the results for Apple stock, right? So that is why we are using this search tool also. And then here we defined 4 agents. The first one is data analyst agent to identify market trends, right? And then the next agent is trading strategy agent to develop the trading strategy based on the insights from this data analyst agent. And then the third agent is trade advisor agent. It is to advise the trades based on the trading strategy that the agent developed before. And the fourth agent is risk advisor. So this will provide any insights on the risks with the trading activities, right? And then for these 4 agents, we have defined the 4 tasks, what each agent should do. So this is nothing but prompt engineering, right? So we have defined 4 tasks and assigned to each agent, right? So once we created the tasks and agents, the next step is creating the crew. So here we created the crew by instantiating this crew class, and we passed agents, tasks and manager LLM. For the LLM, we are using OpenAI GPT 3.5 Turbo, and the process is hierarchical, right? Because the manager LLM has to approve. right? So that is why we are using this hierarchical process, and verbose is equal to true. We want to see the complete execution log, and here we define the input data. Instead of Apple, you can replace this with any other stock, right? And then inside Crew, we have the method called kickoff. For this method, we are passing our input data as value to this inputs attribute, and we get the final result, right? And here we are trying to just write the content from this result to this file. This is the markdown file, right? So this is how we are able to build a multi-agentic stock trading platform project by using CrewAI. All right. Thank you. So far we learned different components of LangChain, that is prompt engineering, chains, memory, agents. Now we also have tools. That is, we can provide different tool access to LLM so that the LLM can access outside world, right? So now let's go to VS Code, and inside our tools and agents demo, let me create a new Python file, and here we will be using Epify, and by using Epify, let's try to scrape a website. Okay, so that is the project we will be implementing now. So let's save this file as web scraping using Epify. So we will be scraping a website by using Epify. In order to use the Epify, first thing is you need to get the API key, right? So let me take you to the Epify official web page. So this is how it looks. Scrape TikTok profiles, extract places from Google Maps, download Instagram posts, crawl website to feed AI, extract products from Amazon, right? This Epify is your full stack platform for web scraping, right? So this is one of the web scraping tool. So if you notice here, we have different actors which you can use to do various activities, right? So you can do the TikTok data extraction, or you can scrape Instagram or Google Maps extractor or website content crawler. This is the one we will be using now to scrape a website. And you can also scrape Amazon, right? Or you can build your own actor also. Instead of using the existing actors, you can build your own actor also. So this is the official Epify platform. So here you can click on login and then click on sign up, and you can sign up with your Gmail account here. So you can continue with your Google account and click on sign up, right? So once you create an Epify account, then click on login and provide your email address and password and click on login. So this is how it looks once you log into Epify. So once you create an account, Epify will provide you some free credits. So before you recharge your account, make sure you use your free credits, right? So once you log into Epify, click on settings, API and integrations, and here you can see your personal API token. So click on this to copy your API key and then store this inside your environment variable. So that is how you can create an Epify account and then get your API key. So we use this Epify to scrape websites, right? So here, let's try to create API key for Epify also, Epify API key, and then whatever the key that you get from your Epify account, make sure you replace here, right? So that is how you will store your API key inside this environment file. And now, first thing is we know we have to install all the required packages. So I have already installed these packages, that is LangChain Epify. So we are using a LangChain package, that is LangChain-Epify, and we are also installing LangChain community and then Epify client, right? So make sure you install these three packages in order to scrape a website by using Epify, right? And once you install all the required packages, the next thing is we have to load the required modules. So we are trying to import vector store index creator. This is from LangChain indexes, and then Epify wrapper. We got this one from LangChain Epify package, right? So we have to install this to use Epify wrapper, and also this document from LangChain core documents, OpenAI embeddings. You know this already, in order to create the embeddings, and we are using OpenAI as our LLM. And this is to load the environment variables, right? Now, first thing is let's try to load the environment variables by using load underscore dot env function, right? And then the next thing is let's try to read the API keys. So we are reading OpenAI API key and also Epify API key, right? So make sure you give the same name inside this environment file, okay? Whatever name you are providing inside this environment file, you have to give the same name so that you will get the key, right? So once you read the API keys, the next step is store these inside the environment variables, right? So OpenAI API key and also Epify API token. Now, the first thing is let's try to instantiate Epify wrapper. So this is the Epify wrapper class. And if you want to read more about Epify wrapper, so this is the official documentation from LangChain. So you can go through this and see what kind of parameters or functions that this class supports, right? So once you instantiated this class, now let's try to call the method call underscore actor to crawl a website, right? So let's try to print call website content crawler. So inside Epify wrapper, we have a method called call underscore actor. And if you notice here, we have different parameters inside this method. So we are passing actor ID as Epify slash website content crawler. So this is the actor that we are using. And in case if you are using different actors, for example, Amazon or Instagram, right? So then you have to replace this actor. And here we are trying to crawl a Wikipedia website. Instead of this website, you can replace with any other website and see if you're able to scrape the content, right? And this is nothing but the document page content is equal to item of text and metadata is equal to source item of URL. We are trying to provide the source also, right? From where this content has been scraped, right? So that is what we are giving here. So by using this call underscore actor method, we can pass the website that we want to crawl, right? So now once we get the data, we have to convert that into embeddings, right? Because we know LLM cannot understand text and it can only understand numbers, right? So let's try to define the embedding model. Here we will be using OpenAI embeddings. So we created our embeddings. Now the next step is let's try to compute the embeddings by initializing the vector index from the crawled documents, right? So we stored our document inside this loader. So here we are trying to initialize the vector index, which is from vector store index creator, which we have imported from LangChain indexes. For the embedding, we are giving our embeddings model, which we have defined before, that is OpenAI embeddings. And inside this vector store index creator, we have a method called from underscore loaders, from where we want to load this, right? We stored our scrape data inside this loader variable, right? So that is what we are trying to pass here. And once we created the vector index for our crawled document, the next step is let's try to initialize the LLM. So here we are using OpenAI, which we have imported from LangChain community LLMs. So here we initialized our LLM and we are using OpenAI as our LLM, right? So now this is nothing but a RAG application, right? So we scraped a website, which is nothing but our Wikipedia website. And we scraped this website content and we stored inside this loader variable. And we created the embeddings and we initialized the vector index and we stored inside this index variable, right? Once you convert the content into embeddings and stored inside a vector database, meaning you can ask any questions from this website, right? So now this is nothing but a RAG application, right? Because we scraped the content. This content is from a Wikipedia website. We scraped the content by using Epify website content crawler actor and we stored inside this loader. And then we created the embeddings. We are using OpenAI embeddings. And then we created the vector index by using vector store index creator and we passed our data, right? So now once you have this, you can ask any question. So now let's try to ask any question and see if it is trying to answer or not. So the query is, what is generative artificial intelligence, right? Now, let's see if our LLM is able to answer. Index. This is where we created our vector index. Inside that, we have a method called query with sources, and we have to pass our input, that is the query, and also the LLM, which we have initialized before, right? That is our OpenAI LLM. And once we get the results, let's try to get both the answer and also the source, right? So let's print the result and also the answer as well as the source from where it is trying to get the answer for us, right? So it is kind of a chatbot, right? So you can read the content from a PDF instead of this website, right? And you can try to implement different scenarios here, right? So let me save this code and let's try to click on run and see if we are able to see the results or not, right? So let's click on the run. So you can see it is trying to create the embeddings and then it is able to scrape the website. And what is the question that we asked? What is artificial intelligence? That is the question and this is the answer, right? So let's quickly review what we learned here. So here our intent is to scrape a website by using Epify, right? So the first thing is we have to install all the required packages. So let me close this. And let's minimize this as well. So the first thing is we installed all the required packages, that is LangChain Epify and LangChain Community and Epify Client, right? So these three are the required packages. And once you install the packages, and the next step is loading all the required modules, right? And here we are trying to load the environment variables from this .env file where we stored our Epify API key, right? And here we are trying to read the API keys. One is OpenAI API key and also Epify API token, and we are storing those two inside these environment variables. And then we instantiated this Epify wrapper class, which is from LangChain Epify. And then here we are trying to pass the website that we want to scrape, right? And then the actor that we are using is website content crawler. And inside this Epify wrapper, we have a method called call_actor, and we are setting these parameters. And then we initialized our OpenAI embeddings because we know LLM cannot understand text. So we are trying to create the embeddings. And then here we are initializing the vector index. For this, crawled documents, right? And then here we are trying to initialize the LLM. And then next thing is inside this vector store index creator, we have a method called query with sources. So we are passing both our query, what is our input, and also the LLM, which is nothing but OpenAI LLM. And it is able to scrape this website and was able to answer the question, what is generative artificial intelligence, right? So from this website, okay? So that is how you can use Epify to scrape any website, and you can build different scenarios here, right? So here, instead of this website, you try to replace with your own content. For example, let's say read your content from different data sources, for example, PDF or Word doc or different data sources, and try to store this here. And this is kind of a RAG application. So once you create this vector store, the next step is you can try to ask different questions, right? So that is how you can use Epify to scrape a website. All right. Thank you. So far we have seen different components of LangChain, that is prompt engineering, chains, memory, agents, and tools. And we have also seen RAG, right? So how to build RAG applications as well. And now let's see how we can empower an LLM by providing access to different tools. Now let's go to VS Code and try to build an application around these tools, right? So this is our tools and agents demo folder. So inside this file, new file, Python file, and let's save this as math tools agents use case, right? So we will be using math tool, which is inside LangChain chains. So the first thing is we have to make sure we install LangChain OpenAI, right? So in order to use the OpenAI LLM, so we will be using OpenAI as our LLM. And once you install LangChain OpenAI package, the next thing is we have to import all the required modules. And in case if you do not want to use this paid LLM OpenAI, you can also choose any other open source models too. right? For example, you can replace this OpenAI with Olama or any other open source models from Hugging Face, right? So you don't have to just rely on this OpenAI. Okay, so here we are trying to import LLM math chain from LangChain chains and tool from LangChain agents and OpenAI from LangChain LLMs and load.env from .env and OS module, right? So the first thing is we have to load the environment variables from .env file. So this is where we stored all our environment variables. Inside this environment file, we stored our OpenAI API key. So now first thing is we used this load_.env function from .env, and by using this we are trying to load the environment variables, right? And then the next thing is let's try to read the API keys. So we are trying to read OpenAI API key and storing that inside OpenAI API key variable. Okay, and now let's try to store this OpenAI API key inside this environment variable, right? And let me close this. And the next thing is let's try to initialize OpenAI LLM, right? By using OpenAI, which is from LangChain LLMs, right? Now, here we are using LLM math chain, right? So let's try to initialize LLM math chain as well. This is from LangChain chains. So that is our next step. So far we have initialized our LLM, which is nothing but OpenAI, and then we also have LLM math chain to bind this LLM with the tool, right? So that is why we initialized our LLM math chain. And the next one is let's use this tool class, which is from LangChain agents, and initialize our math tool. Okay, initialize this tool class, which is from LangChain agents. Here we are trying to set the parameters, name as calculator, and function is inside this LLM math chain we have a function called run. So that is what we are telling this tool to use. And what is the description? Useful for when you need to answer questions about math, right? So this is the math tool. So that is how you can create a tool. Okay, so far we have initialized our LLM, and we also have our math chain, which is LLM math chain, and inside that we have a function called run. So that is the function we are telling it to use, and we also initialized our tool. Okay, now when giving this tool to LLM, we must pass this tool as a list. Okay, so here we are trying to give this math tool to our LLM OpenAI. Okay, and we must pass this as a list. So remember that. And now inside this LangChain agents, we also have another module called load_tools. So let's try to load that module as well, load_tool. So this is another function which is inside LangChain agents. Let's use that load_tools function, which is from LangChain agents. So load tools based on their name. Tools allow agents to interact with various resources and services like APIs, databases, file systems, etc. So that is the intent of using tools, right? And here we are giving the tool name as a list, and we are assigning the LLM, right? So far we have initialized our LLM and then LLM math chain, and we created our math tool as well. Now let's initialize the agent, which is again from LangChain agents. So we have a function called initialize agent. So by using that, let's try to initialize an agent. So our agent is 0-shot React description, and for the tools we are passing whatever tools we have created, that is our math tool, and this is the OpenAI LLM, and verbose is equal to true and max iterations is equal to 3. So once we have the agent ready, for this agent we assign tools, we also assign LLM, and now let's try to ask a math question and see if this agent is able to perform or not. Okay, so for this 0-shot agent, let's try to ask a math question. What is 4.5 times 2.1 to the power of 2.2? So this is our question. And also let's try to print this so we can see in the terminal. Let me try to execute this. So you can see this is the output our agent has given us. Okay. So now let's see if it is actually correct or not, right? So let's try to cross verify this. So let's try to just print this value. So let me create this session and rerun the code. So now you can see both are giving the same result, right? So that means our agent is trying to calculate the correct value for the math question that we have asked, right? Let's try to ask another math question. Zero shot agent. If Mary has 4 apples and Tom brings 2.5 apple boxes and each apple box contains 8 apples, how many apples do we have? So this is a math question that we are asking to our agent. So now let's clear this, and also I'm commenting this print statement, and now let's rerun the code. So let's try to understand the output first. So for the previous question, we asked what is the value of this math question. So entering new agent execution chain, I should calculate the expression using a calculator, and the action is calculator. Action input is, this is the input, and the observation answer is this. And what is the thought? I now know the final answer, and it gave the final answer, right? So this is how the agent performed the task. And then we also asked another question. Entering new agent executor chain, we need to calculate the total number of apples. So it understood it need to calculate the total number of apples for this question, right? So what is the input? First, Mary has 4 apples and Tom brought 2.5 apple boxes, and each box contained 8 apples, right? So 2.5 times 8, and the total answer is 24. And the thought is we have 24 apples in total. So the final answer is 24 apples, right? So that is how it is able to calculate the math questions, right? And now let's try to ask another question. What is the capital of the United States of America, right? So this question is not a math question. So now let me kill this and then rerun the code and see if it is able to answer this generic question, right? So you can see raised error, variable node, object is not callable. Please try again with a valid numerical expression. Is this a numerical expression? No. Unfortunately, we end up hitting an error. This is because the agent is enforcing the use of a tool, because we are trying to use the math tool. So what is the workaround? We have created math tool. So we have to add another tool that can answer this generic question, right? So far, whenever we asked any math question, it is able to understand and give us the answer. But when we ask this generic question, it is not able to answer. So we have to create another tool so that the agent will be able to answer this general knowledge question, right? So we just need to link it to an LLM tool, right? So let me comment this, and now let's close this as well. And let's see how we can add another tool. So the first thing is, let me try to import prompt template from LangChain prompts and then LLM chain from LangChain chains. Before we used LLM math chain, and now let's use LLM chain instead of LLM math chain. Now we are using LLM chain because it is able to answer only questions that is related to math, right? So that is why we are using LLM chain now. So we can create a generic tool, and now let's try to initialize the prompt template. So this prompt template is from LangChain prompts, and we are passing input variables query, and the template is equal to query. And instead of LLM math chain, let's try to initialize LLM chain, right? So this again we imported from LangChain chains, right? So when we created this math tool, here we used LLM math chain. Instead of this LLM math chain, let's try to use LLM chain. And let's create an LLM tool. So notice here, this is the LLM chain dot run, and here we used LLM math chain dot run, right? So that is the difference. You can see the description here. Use this tool for general purpose queries and logic. If it is math related questions, then use this math tool. If it is general purpose questions, then use this tool, right? So now let's try to append this LLM tool to math tool. Okay, so we have stored this inside tools, right? So let's try to append tools dot append, and we are appending this LLM tool as well. So now we have both math tool and also LLM tool. So once we have the tool ready, now let's try to initialize the agent. So this is our agent, zero shot React description, and for the tools we assign the tools. This tools contains both math and general LLM tool as well. And for the LLM, we set this LLM and verbose is equal to true, max iterations is equal to 3, right? So with this, we should be able to ask either math question or any other generic question as well, right? Because we have provided both math tool as well as this LLM tool, because we are using LLM chain here, right? So let's try to ask this generic question now. Okay, so save it. And also let's try to ask another math question as well. So here we are asking both generic question and also math question. So let me save this code and rerun the code. So this is the first one, and then the apples question. And then if you notice here, this is the generic question we asked after adding the LLM chain, right? So what is the capital of the United States of America? In the observation, the capital of the United States of America is Washington, DC, right? So it is able to answer now. And we have also asked math question as well. So it is able to answer both generic question as well as math question, right? So that is how you should be able to provide different tool access to LLM, right? So let's quickly review what we learned here. So the first thing is we try to install all the required packages. So we have already installed this package when implementing the previous applications, right? So in case if you haven't installed already, make sure you copy this pip install LangChain OpenAI and go to the terminal and give this command and hit enter. So that way this package will be installed. And once you install the package, the next step is we are trying to load all the required modules from LangChain. And also we are importing load_.env function from .env module. And by using load_.env function, we are trying to load the environment variables from .env file. So inside this, we stored our OpenAI API key, and we are trying to read that key, and we are storing inside this OpenAI API key environment variable. And the next step is we initialized our OpenAI LLM, and here we are trying to initialize LLM math chain. So this is specific to math related, right? And once we have the LLM and the LLM math chain ready, next thing is we are trying to create a tool. Here we initialized this tool class, which is from LangChain agents, and the name is calculator. Function is inside this LLM math chain we have a method called run. So that is the function we are assigning to this, and the description is useful for when you need to answer questions about math, right? So this is how we created the math tool. And remember, whenever we are trying to give tools to LLM, we must pass this as a list, right? And then we use this load_tools function from LangChain agents, and we are giving the description, and we assigned our LLM which we initialized before, right? And once we have the LLM and tools ready, the next thing is we initialize the agent, and we passed the tools LLM to our agent. And the next thing is we asked a math question and the agent was able to get the answer for us. And then we cross verified and it was able to give us the correct answer. And then we asked another math question, it was able to give us the answer. And then we asked a generic question and it was not able to answer because it is not related to math. So that's why we created a LLM tool. Instead of just math tool, we created another generic purpose tool and we appended both. Right here, notice we are using LLM chain instead of LLM math chain, and we are calling the run function and assigning this to this parameter, right? And here again we initialized the agent, and here notice we are assigning tools. This tools contains both math tool as well as this LLM tool, right? So that is why it is able to answer both the questions. Either it is general purpose question or math question. So that is how you can provide different tool access to an LLM so that it can perform different tasks for us. All right. Thank you. So far we have seen how to create multi-agentic applications by using CrewAI, and then we also learned how to provide different tool access to LLM like math tool, and also we learned how to use Epify and scrape a website, right? And now let's see how to provide an LLM access to tools like SQL database toolkit, and also how to use SQL alchemy and how to create an SQL agent and perform different SQL operations, right? So let's try to create a new Python file and let's save it as SQL database tool SQL agent and click on save. And before we start anything, make sure you install LangChain OpenAI package in case if you haven't installed already. That way we will be able to communicate with our OpenAI LLM. Okay. And now once you install the package, the next thing is let's try to load the required modules. So here we are using OpenAI, which is from LangChain LLMs. This is to communicate with our OpenAI LLM. That is the one we will be using as our LLM. And then get OpenAI callback. So this is from LangChain callbacks. So here you can see the description. This is used to get the token and the cost information, right? So that is why we are using this function. And then the next one is load underscore .env. This is from .env and also the OS module, right? Now inside this .env file, we stored our OpenAI API key. I've already shown you how to get the OpenAI API key in the previous lectures. So make sure you get the OpenAI API key and store it inside this environment file. And once you store the API key inside this environment file, now the first thing is let's try to load the environment variables from this environment file by using load underscore .env function. And then the next thing is let's try to read the API keys by using OS module .getEnv function, and this is the key name, right? So whatever the name we stored inside this .env file, we are giving that name so that we will get the API value. Okay. And once you read the API key, next thing is let's try to store this inside this environment variable OpenAI underscore API underscore key. And now let's try to initialize our OpenAI LLM. So we imported this OpenAI from LangChain LLMs. So we are using OpenAI as our LLM. And now let's try to define a user defined function that can return the total number of tokens spent. Okay. So this is a function that is count underscore tokens. This is our own function. This is not built in. And here we are calling this function, which is from LangChain callbacks. And by using this, we are trying to get the token information. That is the total number of tokens spent. By using this function, we are trying to get the attribute value. That is total number of tokens. And we will call this function to get the total number of tokens spent. Okay. And in case if you want to learn more about this, you can always go to LangChain and try to read more information, right? So let me quickly show you. This is the LangChain official documentation for get underscore OpenAI callback function. So you can always go here and see what are the parameters and how to implement this function, right? So you can see the example also. And then the next thing is we are trying to import metadata from SQL Alchemy. Okay. So this is the official web page of SQL Alchemy. So SQL Alchemy is the Python SQL toolkit and object relational mapper that gives application developers the full power and flexibility of SQL. So by using this SQL Alchemy, we can map database tables to Python classes. So that is the intent of using SQL Alchemy. Okay. That is what we are trying to use here, and we are trying to import metadata class which is from SQL Alchemy. And now let's try to initialize metadata and assign that to metadata object variable. Okay. So this metadata, this is a container object that keeps together many different features of a database. So if you want to see the documentation, let me take you there. So this is the complete documentation of metadata class which is from SQL Alchemy. So here you can go through how to import and how to create an object and how you can create a table and utilize it, right? So you have the complete documentation here. So you can go through if you want to explore more. Okay. So we have initialized our metadata object. And now the next thing is let's try to import column, integer, string, table, date and float. So we are trying to import different classes again from SQL Alchemy. So our intent is to create a table. So let's try to create a table. So we are trying to initialize this table which is from SQL Alchemy, right? So we initialized our table class and we assigned that to stocks variable, and the table name is stocks, and the metadata object which we have created before. And then here we are trying to create 4 columns. The first column name is observations. So in short, we are giving OBS underscore ID. The data type of this column is integer and the primary key is equal to true. So that means this is the primary key. And the second column is stock underscore ticker and it is of type string and we are allowing 4 characters. Nullable is equal to false. So that means we have to provide the value for this. It is not null. And then price, that is the third column. It is of type float and again nullable is equal to false. And again the fourth column is date. It is of type date and nullable is equal to false. So with this we created this table and named it as stocks, right? And now let's try to import create engine. This is a function again from SQL Alchemy, right? Let me take you to the official page. So if you want to go through this, you have a complete documentation here inside this SQL Alchemy. So the intent of this engine is the starting point for any SQL Alchemy application, right? So this is how it starts: the engine, pool, dialect, DB API and the database. So it's home base for the actual database and its DB API delivered to the SQL Alchemy application through a connection pool and a dialect, which describes how to talk to a specific kind of database or DB API combination, right? So this is the starting point for any SQL Alchemy application, right? So here you have the complete documentation. So you can see here we have to provide the URL in order to create an engine object, right? So here they have given some examples as well, which you can go through, like how to connect to different databases: MySQL, Oracle, Microsoft SQL Server, and SQLite. This is the one we will be using, right? And others. And this is for the API, right? So depending on your requirement, you can implement. And now let's try to create the engine object. So we have imported this create engine function from SQL Alchemy. So let's try to use that function and pass the URL, which is nothing but SQLite. So SQLite is an open source relational database, right? So by using this create engine function, we are passing this and we are getting the engine object. And inside this metadata class, we have a function called create_all. And for that, we can pass the engine object that we have created. So let's try to call the create_all and then pass this engine object. Okay, we have created our table. So here you can see the description of this method. It will create all tables stored in this metadata, right? So with this, we created our table. And now we have to insert the values for these 4 columns. And one of them is of type date, right? So in order to insert date time value, we are trying to import date time class from date time module. And now let's try to insert around 10 values. So the column number 1 is observations ID, which is nothing but the primary key and is of type integer. So that is what we are giving. And stock_ticker, that is the stock name, is ABC. And the column number 3 is price. We are giving as 200. And date, so here we are trying to create a date, 2050 January 1st, right? And again for the second column, 2 ABC, 208 is the price, and 2025 January 2nd. So similarly, we are trying to create the column values for the remaining. So we have a total of 10 column values. So now let's try to insert these values to our stocks table. So in order to insert, so this is for the create, and now we are trying to insert. So here we are trying to import the function called insert, which is from SQL Alchemy. So by using that, let's try to create a function called insert_obs. So here we are trying to define a function called insert_obs. So that is all the observations. So we will pass each observation one by one. So we have a total of 10. We will pass one by one, and here we are trying to call this insert function, which is from SQL Alchemy, which we just imported, and we are trying to insert each value. So the first one is whatever we get from these observations. So the 0th index value is the ID. So that is what we are assigning. And then here it is OPS of 1 means it will give us the stock_ticker. So that is what ABC. And then index value of 2 is 200. So that is the price. And this is the date, right? So that is what we are setting here. So we defined a insert_observations function so that we will pass each observation. We have a total of 10, and we will insert inside our stocks table. And also let's execute this statement, right? So this is our connection object. So we are trying to begin the engine and then execute the insert statement one by one, right? So now let's try to pass these values and call this function insert_observations. So inside observations, this is a list of lists. So we have a total of 10, and for 10 times we are calling this function, and we are passing one by one observation. So for each observation, we are getting each one by one and then passing here to this function, and we are trying to insert the value. Okay. And now let's try to import SQL database. So which is from LangChain utilities. Okay, so we are trying to import SQL database class, and also let's try to import SQL database chain class, which is from LangChain experimental SQL. Okay, let's try to create this SQL database object. So that is the database we will be using, and we are passing the engine object, right, which we have created before by using create_engine. And now let's use this SQL database chain and create an object. So that is the SQL chain, and to this chain we are trying to bind LLM and the database object that we have created, and verbose is equal to true. That is, we are providing SQL database access to our LLM by using this SQL database chain, and verbose is equal to true means we will see the complete execution log in the terminal. And now we have to create the agent. So that is the next step, so that we can assign this task, right? So let's try to import this create_SQL_agent function from LangChain agents. And also from LangChain agents, let's try to import SQL database toolkit class from LangChain agents agent underscore toolkits. Okay, and we also need the agent type. So this class is again from LangChain agents agent types. So once we imported all these classes, now the next thing is let's try to create a SQL agent by using create underscore SQL agent, which we just imported from LangChain agents. So by using this create underscore SQL underscore agent, let's try to create an agent, and to this agent we are setting these values. For LLM, we are setting the LLM which we initialized before, which is nothing but our OpenAI LLM, and we are trying to give the tool access, which is nothing but SQL database toolkit, and here we are setting the database, which is nothing but our SQL database, and the LLM, which is nothing but our OpenAI LLM, verbose is equal to true, and agent type, it is of type zero shot React description. So this is a zero shot agent that does a reasoning step before acting, right? And the max iterations is equal to 3. So now once we created our agent, let's give a task to our agent. So we have provided LLM SQL database toolkit access to our agent. So let's assign a task so that our agent will perform the task by accessing SQL database, right? So here we are trying to call count underscore tokens, which we have defined here. So here we are passing agent and the input query, and we are trying to get the total number of tokens spent for this query, right? So the agent executor is whatever the agent that we have created before. And what do you want our agent to do? This is the query. What is the multiplication of the ratio between stock prices for ABC and XYZ in January 3rd and the ratio between the same stock prices on January the 4th, right? So if you see here, we have January 3rd and January 4th, we have ABC, and we also have XYZ stocks, right? So we are asking what is the multiplication of the ratio between stock prices for ABC and XYZ on January 3rd and 4th, and also the ratio between the same stock prices on January 4th also, between 3rd and 4th for those two stocks, right? So let's try to print the results. So let me save this code and let's run the code and see if our agent is able to execute and give us the answer. So it is trying to enter new SQL agent executor chain. Okay, so this is our input, that is the query that we gave, and the output is agent stopped due to iteration limit or time limit. Okay, but it understood whatever the query we gave, so it formed the query, right? So select price from stocks where stock ticker is equal to ABC and date is equal to either 3rd or 4th, order by date in ascending order. It is trying to sort it. So since we reached the maximum iteration limit, so let's try to increase the iteration limits to, I'm just giving 30. So either we can kill or clear the session. So let's rerun the code. So now you can see the final output, right? So for the stock ABC, this is the January 3rd value 232 and 225 is the January 4th value. So that is what we have created here. So January 3rd for ABC it is 232 and 225 is for January 4th, right? So that is what we are trying to get the ratio. And similarly for the stock XYZ, right? The next thing is what is the multiplication of the ratio, right? So that is what we are trying to get the multiplication value. So it is trying to multiply them and the final answer is this, right? So it is trying to give us the final answer here, output, right? So you can see the complete execution log because we gave purpose is equal to true, right? So here you can see entering new SQL agent executor chain, and this is the action it is trying to perform. SQL database list tables, and action input is stocks. I should query the schema of the stocks table to see what columns I can use, and the action is SQL database schema. Action input is stocks, so it created this table with these 4 columns, right? So create table stocks. So these are the values, and I should query the stock prices for ABC and XYZ on January 3rd and January 4th. So it understood the context. And now action is equal to SQL DB query, and action input is equal to, this is the SQL query that it needs to execute. And again it is trying to calculate the ratio, and the next one is for the stock ticker XYZ, and then it is trying to get the ratio, and then again multiplication, and finally it is trying to give us the answer, right? So that is how we can ask our agent by providing access to our LLM and also SQL database and execute the queries, right? So instead of this, you can try to replace with different questions and see if it is able to give us the desired output, right? So let's quickly see what we learned here. So the first thing is we installed all the required packages. Here we are using OpenAI as our LLM. So instead of OpenAI paid LLM, you can also use any other open source model as well. That is any model from Hugging Face, or you can also use Olama, right? And here we are trying to import different modules from LangChain and also SQL Alchemy. And here we loaded the environment variables from this environment file. So inside this we stored our OpenAI API key. So that is what we are trying to read, and then we assign that to OpenAI API key environment variable. So either you can set here or you can also pass here as well when you are initializing the OpenAI LLM, right? Here we defined a function called count underscore tokens, which will return us the total number of tokens spent. And here we are using the function called get underscore OpenAI callback to get the total number of tokens spent. And then we created the metadata object, and the next one is we created this table, and here we instantiated the stocks table with 4 columns: observation ID, stock ticker, price, and date. And the next one is we created our engine object. This is the SQLite. So SQLite is the open source relational database, right? And then we are trying to create the table by using create underscore all, and we are passing the engine object, and these are the column values we want for all our columns, the 4 columns, and we are trying to insert 10 different values. And again here we created a user defined function insert underscore observations, and for that we are passing the observations one by one here. So for each value we are trying to insert and then execute the statement. And here we are trying to create the SQL database object, and to that we are passing our engine object. Then the next one is we are using SQL database chain to bind our LLM to the SQL database, and verbose is equal to true to see the complete execution log. And once we have the chain, the next thing is we are trying to create the agent. For this agent we are setting the LLM, and we are also providing tool access, that is SQL database toolkit. And for this we are setting our database and also LLM, and verbose is equal to true. Agent type is equal to 0 short React description, so that is the agent type we are using, and max iterations. And then here we are trying to give a task to our agent so that it can perform by using the LLM and also toolkit access. So we are calling this user defined function count underscore tokens. Here we need to pass the agent and also the input query. So agent is whatever the agent we created, we are passing that, and also the query is what is the multiplication of the ratio between stock prices for ABC and XYZ in January 3rd and the ratio between the same stock prices on January 4th, right? So we are getting the result. So that is how you can create an agent and try to perform different database operations. And instead of this SQLite, you can try to connect to different databases like MySQL or Oracle, and try to execute different SQL operations and see if it is meeting your business requirement. All right. Thank you.